have a look at carboxylic acids, the structure of carboxylic acids and the reactions that they take part in. So let's start off with what is a carboxylic acid. Now, this is the general structure of a carboxylic acid. Now, an R group means any chain, right? So this could be a carbon with 3 hydrogens coming off of it. This could be 2 carbons with hydrogens coming off of all those. This could be 2 carbons with another oxygen over here. It doesn't matter what this R group is. This is the bit that is important, right? Now, you have got this oxygen here and you've got an OH. What's really important to note, this is not an alcohol group, because what actually happens in reality is this hydrogen here comes off of it, forms a hydrogen ion or a proton, and this forms a negative. That's not done very well. So this forms a negative oxygen. So this forms a carboxylate. So that would be RCOO minus, and you need to include that minus. And this hydrogen is really important because this is what makes it a weak acid. Because once this is separated, this can then go and join. So this will break this bond here, turn this into that OH group. This bond will be moved to form a double bond down here. So you would then have basically the hydrogen moves from oxygen to oxygen. So it goes like this, right? And it's all, and therefore it's partially dissociated. So it's a weak acid because it never completely leaves. It just bounces from oxygen to oxygen, but it does have acidic properties. Now, how does this stuff form? If I get an alcohol, so let's say this is methanol, sorry. I've got methanol here. This then forms methanal. So this is actually the stuff that gives you hangovers. This is an aldehyde. You don't need to know that yet. That comes up at A level. So this is looking at the GCSE triple. This is what we call an aldehyde. And after that, it turns into a carboxylic acid, which if you drink alcohol is not so bad because it is very soluble and you basically urinate it out. So this is what comes out in your urine. But as you can see, we've got this CH and then the OH group. Two of those hydrogens are going to leave to form a double bond here on the oxygen. This is a carbon, by the way, here. This is just what we call a skeletal way of displaying it. And then over here, we've got the carboxylic acid group. What's really important to remember is that when you name them, the number of carbons, it's the same rule as all organic molecules. So if this was 1 carbon, it would be methanol, and that would be methanoic acid. If there were 2 carbons in this chain here, that would be ethanol. This would be ethanoic acid, or like vinegar, right? And this is a natural process. So a lot of the time when wine goes off, it's because it's been oxidized and it will taste quite vinegary. And that's because the ethanol, the alcohol in it, has been oxidized and turned into carboxylic acid, which makes it quite vinegary, which is also why you get a lot of things like cider vinegar, white wine vinegar, and malt vinegar, which comes from beer. And let's have a look at some of the properties. Now, it behaves like all acids, so it will react with a base and neutralization reaction. What's important here is when you draw, you have a minus just there, and I made that quite unclear again, a minus, and then there's a plus on the sodium. So this would then form a salt, which would be called sodium ethanoate. And then you get water and carbon dioxide, just like any reaction with a carbonate and an acid. Because it's a weak acid, it doesn't react with all carbonates and all bases, because it's not strong enough to do so, especially when it's not concentrated, when it's a dilute weak acid, but it will react. And if to understand kind of where we're at here, if you took ethanoic acid and you compared it with the fizzing of, let's say, hydrochloric acid, a strong acid of the same concentration, this would be a much slower reaction as a result of being a weak acid. However, concentrated can actually be more corrosive than dilute hydrochloric acid.